All right, so let's look at number 11. Go ahead, pause the video and read it if you need to catch up on it. And for this problem, they were comparing two groups. They wanted to compare the stay or the length of stay for the group that received the normothermic treatment with the hypothermic treatment. So they wanted us to construct a 95% confidence interval for the true mean length of the difference between the two. So the type of inference we're going to use here obviously is an interval because they asked us to do an interval. And since we're comparing two groups that are means, we're going to be doing, the mean tells us that it's a t. So this is going to be a 2-sample t interval. So I'll open up the calculator and show you the steps for that. On the calculator, we go to stat, over to tests. And this is a 2-sample z test, but we want to do an interval. So I'm going to look down here, and this is a t interval. This is a 1-sample t interval. We want the 2-sample t interval. So here's the 2-sample t interval, and it's t because it's about means. If it was about proportions, we would do a 2-sample. Actually, I'm sorry. This 2-sample z interval is very rare. It's very unlikely that we'll ever use it because this is a 2-sample interval about means when the population standard deviations are known, which is very rare. So that's why this is a 2-sample t interval. So from here, they haven't given us the lists of data. They've just given us the mean and the standard deviation of both. So they've given us the summary statistics. So we hit stats, and then we put in the first sample. I'll put the normothermic sample, and then the second sample, I'll put the hypothermic sample. So the sample mean for normothermic was 12.1, and the standard deviation was 4.4. And then the sample size was 104. The hypothermic group, the sample mean was 14.7, and the standard deviation was 6.5. And the sample size was 96. So scroll down, we wanted 95% confidence. And then, is this pooled? No, it's not. The only time we do a pooled proportion is obviously about proportions, and it's only if it's a two-sample z test about proportions. So this is not a 2-sample z test about proportions, so we are not going to do pooled. And then we'll hit calculate, and it's going to give me the interval from -4.162 to -1.038. And it's also going to give me my degrees of freedom. So quick note about degrees of freedom. There's two ways to do it. The first way and the best way is there's a long, complex formula to calculate degrees of freedom when you're using two samples. I haven't taught you that. You don't need to do it that way. The way that I've taught is the more conservative method where you pick the smaller sample size, which in this case, smaller sample is 96. So our degrees of freedom is 95. So if you want to work it out by hand, then you'll use 95 degrees of freedom. But moving forward, I'd like you just to use the calculator. So all you have to do is when you calculate your interval on your calculator, make sure your degrees of freedom is written down in the do section with your interval. And then now that I'm looking at the interval, I see that all the values are negative and 0 does not fall in the interval, which gives me reason to believe that one of these two values is larger than the other. So we do have a difference in the length of stays for normothermic and hypothermic. And since we did sample 1 was normothermic and sample 2 was hypothermic, it looks like the hypothermic stays are longer on average because the subtraction resulted in negative numbers here. So this is how we do a 2-sample t interval on the calculator. Great question. So the do section for an interval is worth 4 points, because for a confidence interval, you have to do your point estimate, plus or minus, critical value, and standard error. So that's 3 points: point estimate, critical value, and standard error. And then the 4th point is getting the correct confidence interval. So if you use your calculator for a 2-sample t interval, and you just put the interval and your degrees of freedom from your calculator, and it's all correct, you'll get 4 points because it assumes you got the 3 other ones correct. But if you put the wrong interval and you don't put the point estimate, critical value, and standard error, then you'll miss all 4 points because you wouldn't have shown any of the first 3 and you missed the 4th one.